Yes, hello. My name is Daniel, and I am the sales director for Sunbright Solar in Tucson, Arizona. The topic of this video series today is going to be the 120% rule. This comes from the National Electric Code, Section 705D, number 2. And specifically, it reads 705 is for interconnected electric power production sources. Section D refers to utility interactive inverters. And number 2 reads the following: the sum of the ampere rating of overcurrent devices, now that's breakers, in circuits supplying power to a bus bar or conductor shall not exceed 120% of the rating of such bus bar or conductor. So what does this mean? When installing a solar system, you're generally attaching it with a breaker in a main service panel, and the sum of both the breaker of the solar and the existing main breaker cannot exceed 120% of its bus bar. When you have a service panel, generally you're going to have a main breaker and a bus bar there. The bus bar is what the breakers that feed all the different loads in the house attach to, and that can't be exceeded by more than 120%. Typically, what you find is in most standard service panels that the bus bar and the main breaker are typically equal to each other. So both 200 and 200 in most scenarios. So 120% of 200 is 240. So if you're going to attach a solar system to a standard service panel, your amp limits or your maximum solar breaker cannot exceed 40 amps. You can find this on the label inside the panel, and generally it'll say mains and then bus bar. Mains stands for main breaker, bus bar is what we just discussed there. And if you go into this data sheet, you need to figure out how much solar breaker capacity you actually need to put on there. There's a correction factor between what the inverters put out in a continuous amp rating and what that breaker size would be. Now, that's not 120, it's 125%. So if we were to use the highlighted inverters here, the 7600 model has a 32 amp continuous output current rating. Multiply that times 125%, and you will find that it's 40 amps. Therefore, 200 plus 40 is 240, and we are equal or code compliant for this section 705. However, if we move over to the larger model of inverter, the 11400H, you will see that it requires 47.5 amps of breaker protection, which when multiplied by 125% comes out to 60 amps of a breaker. 60 amps plus 200 amps of a main breaker is larger than 240 amps, and so we are no longer code compliant in this scenario. This issue can be common in two manners. Typically, when you have a larger solar system, or if you have a smaller main service panel, typically you see those at 100, 125, or 150 amps for either smaller dwellings or just older services. And in that case, the math gets even worse. So 100 or 125 can only support a 20 amp solar breaker, and then 150 is a maximum of 30 amps, which is generally an inverter capacity that is AC rated at 6,000 watts or less. So that can severely limit the size of a solar system that can be put on a house. In addition to that, larger houses also have 400 amp services. But in my experience, I've only seen one true 400 amp service. 99% of 400 amp services are effectively two 200 amp services. Now, the wires that feed from the transformer through the meter are generally rated 400 amps. The meter itself and the meter enclosure is 400 amps, but as soon as it leaves that, it splits into two separate legs. Generally, you'll find one at the enclosure itself, which will have a 200 amp main breaker and a 200 amp rated bus bar, and then a secondary breaker that feeds a secondary service, generally inside of a house that has breakers there, and that splits the 400 amps into two 200 amps. So this rule still applies, leaving you with a 40 amp breaker as a maximum capacity. However, oftentimes when you have these 400 amp services, you also have a larger square footage house, and then you'll need a larger solar system, making the math even harder. The good thing is we do have several options to overcome that. The most common one is a derate. The derate simply manipulates the math by reducing the utility feed into the service panel. So instead of having a 200 amp main breaker will have 150 or 175 amp main breaker, and then the math changes. If it's 175 amps, that'll leave 60 amps of capacity when you subtract the 240 or 65 amps, making that 60 amp breaker applicable and code compliant, allowing us to put into effect a larger solar system into the house. If we were to derate down to 150 amps, we can accommodate 90 amps, which is very good for microinverter applications or just larger systems in general. Another and new to the market is a connector known as a meter collar. A meter collar effectively bypasses this rule by bypassing the main breaker panel itself, in that it's attaching at the meter joint. So the existing meter comes out, this meter collar goes in, the meter goes back in, and then what you see in that picture is a feed. This thing is capable of handling 48 continuous amps, and it has a 60 amp breaker for overcurrent protection on the top. Because that 11.4 model of inverter could supply 47.5, it is then applicable to go on here, and this allows us to put this 11.4 model on basically any service. So that could be 100, 125, or even the standard 200s, and it allows for a larger capacity inverter. Another option are solar ready panels. Now, these are somewhat common in newer builds, and some home builders are putting them in as standard. So it's a good idea to check if you have a newer home and go see if you already have a solar ready panel. Solar ready panel just means that the bus rating has been increased. So instead of 200, typically you find it at 225. And when you apply the 120% correction factor in it, you'll get up to 270 amps. So you can keep that 200 amp main breaker. 70 amps is a lot. You can put in the 11.4. It only requires 60 amps of backfeed capability. And in addition to that, you can also derate these main breakers. So a combination of the two, derating and having a solar ready panel, allows for probably the largest systems we can place into service without requiring large quantity of cost and scope of work service upgrades. So solar ready panels are great, but they are somewhat costly because we are replacing the entire panel itself. Another and last option I'm going to discuss here is a line side tap. There is a such thing as a load side tap, but a line side tap is much more common in that we are also bypassing, just like the meter collar, the service panel and its bus bar and those requirements there. In this one, you'll have a meter and a main panel and wires feeding the two. You go to the wires, you intercept them, and then you feed your solar into that, your main panel into that, and then that junction box also feeds the meter. Allowing you to place probably the largest systems into service and bypass the older service panels or lower ampacity panels there. However, line side taps can only occur in a separate junction box. And in this territory, Tucson, Arizona, we do have a high level of what we refer to as all-in-one panels. An all-in-one panel means the meter in its enclosure, the main panel, its breaker, and all its sub-breakers are all in one enclosure. That's the image depicted on the left. And because you cannot make these connection points inside the housing of this main panel, that voids the warranty, they will not permit or allow it. It's not code compliant. Line side taps can only occur when you have a meter main combo or separate meter and distribution load center. That way you can mount this junction box and run the wires into that. There's a few more nuanced rules that go into it, which eliminate some applications there, but for the most part, a line side tap is applicable if you have a meter main combo, just not if you have an all-in-one, which many panels are all-in-one. You would have to revert back to some of the other previously discussed options. If you have any questions about any of this, I can be reached at 520-330-6942 or Dan at sunbrightsolaraz.com. Thank you very much. I hope you learned something. Dan.